we are going for a different M array modulation schemes. Okay. So at the source side, we have to generate unique signal for symbol. If I go for 64 QAM, okay, then I need 6 unique symbols. When I go for a 64 unique symbol, 64 different signals I have to generate, but it is not possible to have 64 sources from the tapping the signal and transmitting. Okay, it is too much costly. To avoid that, what we are trying to do, we are trying to generate 64 different signals. Okay, with the help of less number of sources. Okay, that's the thing we'll call as a linear combination of all the base function going to provide me all the linear combination of the base functions are going to provide me the signals. Okay. Now, how much contribution for each base function? Okay, that will call as a coefficients. That we are trying to make as a vector. That we are trying to make as a vector. Psi1 this much amount, psi2 this much amount, psi3 this much, psi4 this much, and combination of psi1, psi2, psi3, psi4 with the corresponding proportion is going to give me S1. The same way, psi1, psi2, psi3, psi4 with a different proportion, it is going to give me S2. Okay, so like that 64 different symbols I can able to generate. Okay, the same thing we are trying to do it now. Okay, so you assume any modulation scheme. Okay, you try to create a binary representation or multi-amplitude level representation. Okay, you create a rectangular pulse for each signal. Okay, everything is going to your own choice. Okay, only condition I am putting, it should be a rectangular pulse and m value should be more than 60. M value should be more than 60. You can have a multi-amplitude representation. Okay, so you create 16 different symbols, S1, S2, S3 up to S60. Okay, different signals you try to generate. Okay, then you try to decompose your signal. Try to decompose your signal with the help of a Gram-Schmidt orthonormalization. You try to decompose the signal. So when I try to decompose, what I'm going to do, take any one signal. I'll assume that is going to be my base function. That is going to be my base function. Once I created the signal, okay, I'll keep that as a reference. I'll try to produce one more signal. Okay, what is the condition I'm going to put? First signal and second signal, whether any contribution available. Okay, if there is available, you remove that. Okay, what are things not available, that you try to use it and try to ensure that there is going to make us a orthogonal representation. Okay, that is the way we are trying to do. Okay.
Sir, you are not sharing your screen, sir.
Yeah, one second, one second. Are you able to see the screen now?
Yes, sir.
Okay. So I had a problem. So these are my signal set, S1, S2, S3 up to SM, M different signals. Okay. Now I'll try to express all the signals. Okay. Generally I'll call S subscript small m. Okay. That is the sum of t. That is equal to summation. Okay. What are the things? I will consider base function psi I of t. Okay, and here I'm going to have a coefficient. That coefficient I'll write as a C, I, and M. Okay, so I changes from 1 to capital M. Okay, and the index I I'll use to express the base function, and this CIM I'll use this particular base function, how much contribution I'm taking to get a sum of t. Okay, so now to get these values, okay, I'll take the signal, I'll project on the base function, I'll get it. Okay, now I have only these things. From this I want get psi 1, psi 2, psi 3, psi 4. Okay, so what I'm doing, I have to get psi 4. So to achieve that, I'll take a signal. Okay, so I'll multiply so I'll take a signal. Okay, first I'll take S1 of t. I'll compute the energy of the signal. I'll compute the energy of the signal and I'll take a square root. Okay, energy of S1 of t, that is going to give a base function psi 1. Okay, next I'll keep this as my reference. Now, based on this reference, I'm trying to create next base function. So what I'm doing, so I'll go with the next signal S2 of t. In the S2 of t, I'll check is there is any contribution from the psi 1. Is there is any contribution from the psi 1. That value I'll compute. Okay. So that value I'll say it's a coefficient. So in that second signal, I have this much amount of psi 1 is present. Okay. So the C21 out you are going to find, we are doing as an inner product. Okay. Take a signal S2, project on a psi 1, whatever result you are getting, that is going to be a projection that will give you the contribution. So this is going to give you my result. So here what I did, I took a vector. Okay. Now from here, I subtracted the contribution. Okay. And based on that, I created my second orthonormal basis. So this is going to give you the orthogonal signal. This one I am going to call as a D2 of t. Okay. Once I found the D2 of t, I'll find the energy of D2 of t. Okay, I'll normalize, I'll get a psi 2. Okay. The same way, when I go for a psi 3, I'll try to compute the D3 of t. How to compute the D3 of t? From the S3 of t, contribution from psi 1, contribution from the psi 2, I'll remove it, and from that I will try to project. Based on that, I will get a psi 3. Okay. So this is the way you are expected to implement. Okay, you are expected to have signals a rectangular representation. Okay. So S1 I will try to map in this way. S2 I will try to map. Okay, something in this way. And S1 I will try to have something in this way. Okay. So you decide your signal. Okay, but you try to have maximum number of signals, then only you can able to understand better. Okay, and you try to decompose and you show me the base signals. Okay, and one more thing also you are expected, you have to show me the coefficients. You have to tell me the coefficient for S1, how much amount of psi 1 is there, how much amount of psi 2 is there, how much amount of psi 3 is there, how much amount of psi 4 is there. Okay. Okay, so you have to plot S1, S2, S3, S4, F2, S1, that is one signal. Other one, psi 1, psi 2, psi 3, psi 4, other signal. Then finally, I need a matrix that I need a table. S1 can be expressed psi 1 this much, psi 2 this much, psi 3 this much. In that way, I need the table. Okay, so this is the thing expected from you. Okay, it's not a vector. I'll trying to implement. I am asking to implement with the help of a signal sets. Okay, try to do it. Okay, so it's a vector, is a simple thing. It's a dot product, will going to give a result. Here we have to integrate, we have to find the inner product. Based on that, you have to get a result. Okay, so try to complete it. Today evening we will have a quiz for this experiment and the last experiment. Okay, if you have any question, you can raise.
Sir, we don't have quiz for last two experiments.
That's why I told no. Last two I have not conducted. One I will conduct with this today. Okay. Other one will manage next tomorrow. Okay.
Okay. Okay.
Okay. Okay. Okay. If you have any rights, you can raise. Otherwise, we will leave. Any question? Any doubts?
Excuse me, sir.
Yeah, tell me.
Sir, I'm Vishwanath Singh.
Yeah, tell me.
Sir, I actually missed the two tests that were there for the first two experiments due to a family
Yeah,
emergency.
I saw
I,
your message. Manage it. Okay. I try to manage the quizzes.
okay, understood, sir. Thank you, sir.
Okay.